A remarkable revelation made by the James Webb Space Telescope has uncovered what appeared to be city lights in space, discovered 7 trillion miles from Earth. This extraordinary finding has sparked interest in the potential for extraterrestrial life. The telescope focused on Proxima Centauri b, the nearest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri b? Could this indicate the existence of life beyond our planet? Join us as we explore how the James Webb Space Telescope identified these extraordinary occurrences in space. For years, scientists and the public have speculated about the possibility of life. Any evidence beyond our solar system supporting this dream of space exploration has been met with excitement. Recently, mainstream scientists were stunned when the James Webb Space Telescope detected strong signs of life in space. While studying the cosmos and transmitting data back to Earth, the telescope spotted strange sitter-like lights flashing from the exoplanet Proxima Centauri b. These lights, as their name implies, seem to illuminate a distant metropolis. The possibility of an alien city existing on this star has left researchers astounded, as it could be the breakthrough they've long hoped for. Because if this is the case, as many believe it might be, it would suggest the presence of intelligent life forms constructing civilizations far beyond human comprehension in outer space, and we are just beginning to find them. Investigating these city lights found 7 trillion miles from Earth, NASA engineers are left wondering how long these lights have been shining in space, waiting for humanity's efforts to advance technology necessary to detect them. David Kipping, an expert from Columbia University, describes the exoplanet Proxima b, where the city lights were discovered, as fascinating. He notes that this star system, the closest to us, has varying warming patterns that differ from those of other planets. While typical rocky planets are known to absorb sunlight, Proxima b emits infrared radiation. Infrared emissions differ significantly from its host star, Proxima Centauri. This suggests an intriguing characteristic. The James Webb Space Telescope, JWST, which can detect infrared frequencies, has revealed a unique heat signature of Proxima b that plays a key role in unlocking the mysteries of its environment. Because of its cutting-edge infrared imaging capabilities, researchers plan to utilize the JWST to delve into the planet's atmospheric secrets. It is expected to help assess the potential for life on this exoplanet. The JWST's infrared sensitivity enables it to study what occurs on Proxima b's night side, capturing even the faintest beams of light in the vast darkness. While this has traditionally been a challenge for space telescopes, the JWST excels at detecting even the smallest emissions from space, making it the ideal tool to verify if the rumors of Proxima b's night-side city lights are true. Any artificial lighting in the universe can be identified by the telescope, provided it falls within a frequency band 1,000 times smaller than starlight. Proxima b has a fascinating relationship between its celestial components and surface features. The day side of the exoplanet is home to numerous solar panels that capture radiant energy from its star. Its spectral edge also reflects incoming light. As Proxima b completes its orbit around its host star, Proxima Centauri, it experiences both day and night periods similar to Earth's. During the day, it encounters intense solar heat, while at night, the planet cools down. Known for fluctuating temperatures, Proxima b's composition plays a key role in determining its climate. If the planet lacks an atmosphere, the temperature difference between day and night will be extreme. Without atmospheric gases to moderate the temperature, the day side will be scorching hot, while the night side will plunge into freezing darkness. The extent of this temperature variation is a crucial subject for astronomers to investigate, as it provides valuable insights into Proxima b's atmospheric composition. Using the JWST's unrivaled infrared imaging capabilities, scientists will be able to analyze the planet's thermal emissions, unlocking important information about its atmospheric properties. Interestingly, the JWST's orbit around Earth aligns with Proxima b's orbital period, allowing for thorough observations of its day and night cycles in just 11.2 Earth days. Since Proxima b is believed to have an atmosphere, the next step will be to examine its atmospheric chemistry to determine its potential to support life. Key indicators of life include the presence of gases like oxygen, water vapor, and methane. If these elements are discovered, they could indicate habitable influences. The method of capturing and analyzing light passing through the planet's atmosphere will be difficult even for the JWST, because of its constrained capabilities in observing distant exoplanets. Despite these limitations, astronomers are looking forward to the arrival of ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2028. The ELT will be capable of probing the atmospheric structure of more distant exoplanets, providing essential data on their habitability. NASA researchers and the general public eagerly anticipate the development of future space telescopes, but the JWST remains, for now, a vital tool in our quest to understand the mysteries of distant exoplanets. Although powerful, the JWST has its constraints and can only study a limited number of nearby exoplanets. For more extensive examinations of the atmosphere, scientists are relying on future telescopes and ground-based observatories such as the ELT. These instruments will work together to enable comprehensive research on distant worlds. Researchers are also contemplating future telescopes to reduce the amount of bright light from a planet's host star, improving the ability to detect faint reflections of light from the exoplanet itself. Using devices like inner masks or large external satellites, scientists aim to block out the harsh brilliance of the host star, much like shielding the sun with your hand to better see a distant object. These telescopes will be able to focus more effectively on the exoplanet, providing clearer data on its atmosphere and potential for life. However, this approach presents challenges, as astronomers will need to differentiate between gases produced by life forms and those created by geological processes such as eruptions from volcanoes. Despite challenges, astronomers are determined to enhance our understanding of exoplanets, to identify signs of life beneath the surface, and distinguish them from potential false positives. The JWST represents a glimpse into the future of scientific advancement in exoplanet research, offering a preview of the extraordinary discoveries that lie ahead as we continue to explore the universe. While no exoplanet has yet been definitively proven to harbor life, the search continues. Are we alone in the universe? For centuries, people have wondered whether they are the only intelligent beings in existence. This age-old question persists, and the search for extraterrestrial life is ongoing. In 1984, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI, which remains active today. Through this non-profit initiative, and data that have transformed our understanding of the cosmos. From stunning visuals of distant galaxies to detailed atmospheric readings of exoplanets, the James Webb Space Telescope, JWST, has opened a new frontier in astronomy. Its unprecedented sensitivity in the infrared spectrum allows it to see further back in time than any telescope before, effectively looking at the early universe just a few 100 million years after the Big Bang. What makes the recent findings around Proxima Centauri b so significant is not just the detection of light but the pattern and regularity of those lights. Unlike natural phenomena like auroras or volcanic activity, which typically exhibit irregular pulses or scattered emissions, the lights observed from Proxima b appear to follow organized grids, flashing in intervals that some scientists believe may suggest artificial origin. This pattern resembles urban street lighting when viewed from space, akin to satellite images of Earth at night. However, the scientific community remains cautious. While the data is fascinating, alternative explanations are also being considered. Some hypothesize the lights could be the result of reflective mineral formations or unique atmospheric interactions with the host star's radiation. Still, others point to the possibility of advanced alien technology, perhaps solar arrays, signal beacons, or even megastructures designed to harvest stellar energy. To validate these theories, a multi-pronged approach is being employed. Spectroscopy is used to analyze the chemical composition of the planet's atmosphere. If biosignature gases like oxygen, methane, or even chlorofluorocarbons, a possible marker of industrial activity, are found, it would dramatically increase the odds of intelligent life. Future missions are being proposed to further study Proxima b and its star system. Concepts such as laser-propelled nanocraft, like those proposed by Breakthrough Starshot, could, in theory, reach the system within a few decades and transmit high-resolution images back to Earth. Though still theoretical, such missions represent the next step in validating what the JWST may have discovered. In the meantime, the world watches and waits. The tantalizing possibility that we are not alone, and that another civilization might be signaling its presence, has reignited public interest in astronomy and space exploration. If these city lights turn out to be artificial, it would not only answer one of humanity's oldest questions but redefine our place in the cosmos forever. Sent back revolutionary data, offering new insights into the universe. While its exoplanets have received most of the attention, galaxies and distant stars have also been part of the unexpected discoveries. The unexpected discovery of city lights in space has led scientists to reassess the possibility of extraterrestrial life. The discovery of city lights on Proxima Centauri b has stunned researchers, and the JWST's investigation continues. Its unparalleled capacity for exploring the farthest reaches of space has brought humanity closer to answering one of the most profound questions of all: are we alone in the universe? As scientists continue their research on the mysterious city lights of Proxima Centauri b, the next steps in understanding extraterrestrial life are filled with intriguing possibilities. Whether these lights are artificial or the result of a natural phenomenon remains uncertain. Some scientists speculate that these lights could be an indication of advanced civilizations, while others believe they may be bioluminescent organisms creating artificial light. In either case, the possibility of artificial lighting from such a distant exoplanet challenges our understanding of life's limits in the universe. As the search for extraterrestrial life continues, the discovery of city lights on Proxima Centauri b has opened a new avenue for scientific investigation. The next phase of research will involve close monitoring of the light emissions from Proxima Centauri b. By carefully studying the variations in these emissions over time, scientists hope to determine whether or not they exhibit patterns that suggest artificial origins, such as those produced by power grids or other technological infrastructure. Such long-term observations will be crucial because they might tell us more about the nature of these lights and whether they are the result of intelligent life forms or an unknown natural phenomenon. In addition to tracking these light emissions, researchers will continue to investigate the atmospheric conditions on Proxima Centauri b. The interactions between the exoplanet's atmosphere, its host star, and its magnetic fields could all play a role in the production of effects that appear as city lights to the JWST sensors. These unique atmospheric processes are still a point of debate between specialists, and more data will be needed to confirm or refute the possibility of an artificial source. The capacity of JWST to observe Proxima Centauri b consistently will be key in answering these critical questions. As technology progresses, scientists will develop even more advanced tools to help analyze distant exoplanets. Future space telescopes and ground-based observatories, such as the Extremely Large Telescope, ELT, will provide enhanced capabilities to detect faint signals and gather data that the JWST alone may not be able to achieve. These new instruments will form a collaborative network, enabling astronomers to probe exoplanets more deeply than ever before. Together, they will advance our understanding of the universe and bring us closer to confirming the presence of life beyond Earth. The search for intelligent life on distant worlds has made significant progress with the discovery of city lights on Proxima Centauri b. While the idea of extraterrestrial civilizations may still be speculative, each new discovery, whether it's a faint signal, strange light emission, or an unexplained phenomenon, brings us one step closer to answering the question, are we alone in the universe? If future research confirms the existence of intelligent life, it could initiate a new chapter in human history. The potential for knowledge exchange, cultural enrichment, and even technological advancements could transform life on Earth in ways we can't yet imagine. However, even if no clear signs of alien life are discovered, the journey of scientific inquiry itself holds tremendous value. Each step forward in our understanding of distant worlds adds to the grand narrative of humanity's quest to explore the cosmos and uncover its many mysteries. The implications of discovering life on other planets are profoundly significant, not just for science but for philosophy, society, and our collective sense of place in the universe. Finding that we are not alone could reshape our worldview, challenging our ideas about life, intelligence, and our role in the vast expanse of the cosmos. It could prompt a re-evaluation of what it means to be human and motivate new collaborations across nations and disciplines to understand and connect with other sophisticated civilizations, should they exist. Until then, the search continues, driven by curiosity and wonder, as humanity looks to the stars for answers. As researchers at NASA and other space agencies keep analyzing the data from the James Webb Space Telescope, they remain hopeful that this mission will help us uncover the secrets of the universe and unlock the greatest mysteries of existence. Whether or not we find signs of life, each discovery brings us closer to the ultimate goal of understanding our place in the cosmos and the potential for life beyond our planet. In the years ahead, the advancement of space exploration will continue with new technologies, better telescopes, and more ambitious missions that will enable us to observe distant exoplanets in greater detail. These efforts will pave the way for groundbreaking discoveries that could forever change our understanding of the universe and our relationship to it. Whether it's the search for alien cities, the study of strange light emissions, or the investigation of distant worlds for signs of habitability, the journey to uncover the truth about life beyond Earth is just beginning. As the exploration of distant exoplanets continues, the possibility of discovering evidence of life, whether through city lights or other mysterious phenomena, could have profound implications on the way we perceive our place in the cosmos. The search for extraterrestrial life is no longer a fringe pursuit but a central goal in modern astronomy, driving global scientific efforts to understand the complexities of the universe. New methods of detecting exoplanets, such as the use of gravitational wave observatories and advanced spectroscopic techniques, promise to provide even more precise measurements. These techniques will help scientists identify planets that may harbor the necessary conditions for life, such as liquid water, stable climates, and an atmosphere conducive to supporting organisms. One of the most exciting developments in this field is the potential to discover signs of life on moons orbiting gas giants like Jupiter and Saturn. With the success of the Europa Clipper mission to Europa and the planned Titan Dragonfly mission to Titan, scientists are optimistic that these icy moons might harbor subsurface oceans where life could exist in forms vastly different from those on Earth. The discovery of life, particularly intelligent life, elsewhere in the universe would fundamentally challenge our understanding of biology, philosophy, and civilization. It could inspire a profound shift in how we approach issues such as sustainability, technology, and interplanetary cooperation. The idea that we are not the sole intelligent species in the universe could lead to new frameworks for cooperation between nations, as humanity prepares to engage in the broader cosmic community. Even without definitive evidence of extraterrestrial life, the ongoing exploration of exoplanets and the study of their atmospheres, compositions, and potential habitability continue to deepen our understanding of the conditions required for life. Each discovery adds another piece to the puzzle, enhancing our knowledge of the universe's potential to support life. As we stand on the precipice of this new era in space exploration, we must remain open to the unknown and prepared for the possibilities that lie ahead. Whether we find intelligent life, microbial organisms, or signs of biochemically favorable environments, each discovery will contribute to humanity's quest to understand its origins and future in the grand expanse of the universe. In the years to come, the search for life beyond Earth will remain one of the most profound and exciting endeavors in human history. The tools, technologies, and international collaborations that we build today will shape the course of future discoveries. The journey to uncover the truth about the universe's vast mysteries is just beginning, and with each passing year, we get one step closer to unlocking the secrets of life beyond our home planet. As we continue to look outward toward the stars, we can only imagine the countless worlds yet to be explored, the civilizations waiting to be discovered, and the knowledge that awaits those brave enough to venture beyond the bounds of Earth. The universe holds secrets that we have only begun to uncover, and the search for answers will define the future of humanity.